Okay, so in question 4, we have a boy on a skateboard moves at 5 meters per second to the right towards point A. At the bottom of the slope, which is 1.6 meters high, is carrying a 4 kilogram parcel. The total mass of the boy on the skateboard and the parcel is 70 kilograms. He needs to increase his speed in order to reach point B at the top of the slope. He decides that if he throws the parcel horizontally, it will increase his velocity, his forward velocity. Okay, so in which direction must the boy throw the parcel in order to increase his forward velocity? Obviously to the left. That means in the opposite direction as he's going. Okay, so since he's going to the right, the answer left is perfectly fine. Give the name of Newton's law that must be used to obtain your answer in question 2. Okay, and this would be, it's not Newton's third law of motion, although I suppose it is, because if I suppose that is a valid answer, because every action has an equal but opposite reaction. So if I throw a parcel to the back, it will apply a force to me in this direction. Okay, so that's good. State the principle of conservation of mechanical energy in a closed system. The total, take that away, the total mechanical energy is conserved and remain constant. It is not in a closed system, that's not the word, but rather in the absence of non-conservative forces. The total of mechanical energy is conserved. So not in a closed system. It is basically a closed system, but with the absence of non-conservative forces, the total mechanical energy is conserved and remains constant. Then calculate the velocity of the boy immediately after the parcel leaves his hand in order for him to reach the top of the slope at point B. So at point A, he throws away the parcel. So at point A, he's traveling, him and the parcel as a unit is traveling. Okay, calculate the velocity of the boy immediately after the parcel leaves his hand in order for him to reach the top of the slope at point B. So here at point A, listen, he needs to increase in order to reach point B. Where does it say he's carrying the total boy, the skateboard? He needs to increase. He decides that if he throws the parcel, it will increase his velocity. Okay, so it's not so clear, but the point is that before he reaches the slope, he's going to throw away the parcel. And so if he's traveling at 5 meters per second, this part is wrong. So especially because here in question 4.4, they tell you calculate the velocity of the boy immediately after the parcel leaves his hand. So there's a before and an after in this question, and there's a change in mass specifically here. So let me do that. So we have momentum before. We have momentum before equals momentum after. Okay, before the momentum, we have the mass of the parcel plus the mass of the boy as one thing, because he's holding it, and then we have the velocity of the parcel and the boy as they are one thing, and then afterwards we have the velocity, the mass of the parcel and the velocity of the parcel being thrown in the opposite direction from where the boy is traveling, who also has a mass and a velocity. So let's just get the information. We have both traveling at 5 meters per second. He is carrying a parcel okay, wait, I'm making a mistake. This is 100% correct what he's doing here. I'm realizing now that we want to reach point B. In order to reach point B, I'm going to need a certain initial velocity. So definitely my velocity at the bottom of the slope must equal my mechanical energy at the bottom of the slope must equal my mechanical energy at the top of the slope. And so I've got my potential plus my kinetic at the bottom, which at the bottom is no potential but all of the kinetic. At the top, same thing, my potential, my kinetic, and I want to have a minimum, I want to at least reach point B, so it's okay if I stop at point B. So it's okay if my final velocity at the top is 0, as long as I reached the max, that height. So I've got, the only problem here is that what he shouldn't have done, what student 1 shouldn't have done, his boy and the parcel, no, he did that fine. He's carrying 4 kilograms. The total mass of the boy, his skateboard, and the parcel is 70 kilograms. Yes. So without the parcel, the boy is 66 kilograms. Perfect. So 66.9.8, that's a half times 66. He's just working all of that out. Let's see what if his calculation is correct. On that side, we've got 66. Whoa, that's way too much. 66 times 9.8 times 1.6 is equal to, and then divide that by the coefficient on this side, which is a half, and the mass divided by 66, and then taking the square root of that. Excellent. 5.6. That's exactly it. So at the top, my velocity must be 5.6. And so, okay, so I apologize, and I didn't read the question properly. But then 4.5, calculate the minimum velocity which he must throw the parcel in order for him to reach the top of the slope. And so this is now exactly what I was calculating here, because that's what I realized is I didn't have the velocity at which the parcel was thrown. And but now I get it. So this total mass we said was 70. The velocity that they both were traveling in was 5 meters per second. The mass of the parcel is 4 kilograms. The velocity of the parcel is what we need to work out. And you'll notice that this is going to have a sign opposite to the 5 meters per second. Plus the mass of the boy is 66, but the velocity of the boy is what we just worked out. We want to have a 5.6 meters per second velocity, so more than the 5. So we are going to have to get some velocity from throwing off this part. Okay, on this side, 70 times 5 is 300, so we've got 4v66, let's do the calculator. 66 times 5.6 is that, and then that's what we get on this side, and then subtracting it on with the 70 times 5, so I'm going to subtract that from the 70 times 5, and I get negative 19.6. So my velocity for the parcel will be divided by 4, negative 4.9. Negative 4.9 meters per second. And that is therefore 4.9 meters per second to the left. Excellent. Let's see if that's what the student did. Excellent. Okay. How will the answer in question 4.4, that's now the amount of velocity I need, be affected if the boy throws the same parcel with a higher velocity in the same direction as in question 4.1? Will it increase? Okay. Okay, so we're talking about the velocity. Will it increase that velocity or decrease? If he throws the same parcel in the same direction but with a higher velocity, yes, it will increase, okay, because exactly of that law that we stated here. If he throws it at a higher velocity, he's applying a greater force, so it will apply a greater force to it. Okay, great. That was a fun question to do. Let's look at question 5.